All right, in this lecture, we are going to cover some wrangle nodes. Wrangles can be very confusing for some students. I've had a number of students send message to me privately saying that they just don't understand them or they don't like programming, so I want to show you how simple wrangles can be. I think what's confusing about them is the concept of the wrangle running over every single point of the incoming geometry. So let's check this out with a very simple visual example of how this works. You don't have to do this in your session of Houdini. You can just watch what I'm doing. You can also download the scene file that will be included with this if you wish to see the examples on your local machine. If you want to follow along and recreate this as we do it on the video here, feel free to do so. Open up Houdini if you haven't. Just hit tab and drop down a geometry node. And we're going to dive in. Let's drop down a grid since that will be very simple to see what we're working on here. We'll just have a flat grid. We're going to back out so we can see the whole thing. Let's just change this down to a 1x1 grid. Now we can go in, just hit the W key so we can see it shaded. So now hit tab and just start typing in wrangle. You're going to see a ton of options here. A lot of these options are repeated and not really necessary to have in this drop down. But SideFX chose to put all these options in here more of a convenience so you have direct access to a certain type of wrangle. But attribute wrangle, detail wrangle, point wrangle, primitive wrangle, vertex wrangle, they're all essentially the same thing. We can just drop down an attribute wrangle and check it out. We can expand this a little bit here. You'll see it automatically defaults to run over points. If we hit tab, type wrangle and drop down a point wrangle and look at it. It's the exact same interface. We can go back and forth. You see nothing at all changes. Same with over on the bindings tab. Nothing at all changes. The only thing changing is the name. There's a lot of nodes in Houdini where they do this. There's multiple entries when you hit the tab key, yet they're very similar. So it's just a convenience so that you could instantly drop down a primitive wrangle. And now you'll see it's automatically set to primitives, but if you had dropped down a point wrangle, you can just change it to primitives if you choose. For now, we're going to stick with points. We can delete all these. Don't get overwhelmed by the options here in the wrangle. Most of them are the same. There's certain wrangles that you'll almost never use. I rarely use a deformation wrangle or a height field wrangle. Never ever used a rig attribute wrangle. Sometimes a volume wrangle if you want to do things like changing the density of a volume sim. But for simplicity, we're just going to stick with our points. So plug in our grid. Now here's the basic gist of a wrangle. Every single point that's in the incoming geometry, every one of these, let's enable our point number, is going to have whatever code you write in here run on it. Every single point will get this code. So if we do something simple like let's set the color to red. Now if you have zero programming experience, I recommend you check out an introductory course on, say, like the C programming language. Even the Houdini help has lots of information. I'll briefly explain what I'm doing, but I'm absolutely not going to go into a in-depth review on how to write code. That would be out of the scope of this example on wrangles. So we can type @cd, and it's capital C, lowercase d. That's how you assign color in Houdini. That is the color attribute. And we can just say is equal to, and now we're going to create a red vector, 1, 0, 0, and click anywhere out of here, and you'll see every single point turns red. If you're unfamiliar with this, this is just how you create a vector in Houdini, a vector being 3 values that are usually associated with one another. So we have red, green, blue. You can access that by typing cd.x.y.z or even cd.r.g.b if you wanted to access individual components of your color. So you might think, well, this is very uninteresting. You could just as easily drop down a color node, plug in, and do the exact same thing. We have 1, 0, 0, so we're creating a red vector. But the power of the wrangle is you can do things on individual points. And one of the things that most of the students seem a little confused about is the pt_num attribute. Okay, pt_num is just the point number. So if you wanted to access an individual point, you could say if. Now, if is a conditional statement. We're going to test for a condition here. We're going to say if at ptnum is equal to, and let's just pick 0.54 since that's almost in the middle. Let's clean this up a little bit. It's typical to do some type of indentation or double space or tab so you can see what are the lines of code that are underneath your if statement. And if we click out of the area here, you'll see now only a single point gets that red value, 54. So let me explain this. Again, if you know nothing about coding, we did a double equal sign here because we are checking for equality. We're not trying to assign 54 to ptnum. If you used a single equal sign, you see it doesn't work. It breaks it because we're assigning, well, we're trying to assign the value of 54 to ptnum. You want to compare ptnum to the value 54. So that's why you use a double equals. Down here, we do not use double equals because we are wanting to assign the red value to CD. So you use a single equal sign. Now, this is something you could also do in a more simple fashion. Let's just Alt and left drag this down, and let's say you wanted to do this exact same thing on 0.54. You could just go up here and type 0.54. And now you see 0.54 also gets the single red value, the exact same thing that's going on over here. But typically this limits your ability to work in Vex on this node because what's happening when you put group up here, now the code is only going to run on whatever satisfies this group parameter. So right now we're just using 54 as the point number. You could have selected a group of points and stored them in an actual group and then access that group here, and then you would only run the code on points that are within that group. So for now, let's delete this. I just wanted to show you that there is an alternate way of doing it. If you've ever watched any of my Houdini lectures, you know there are many, many ways to do the same thing in Houdini. But let's get back to explaining how this wrangle works and why it's doing this. It is still running the code on every single point, okay? So think about it. Let's run through it. Point 0 is up here. So on point 0, it runs this code, and it says, if ptnum is equal to 54, assign the color of red. Well, ptnum, when we're on point 0, is 0. The ptnum is just a self-identifier, okay? Any point you're on is going to be the same as the ptnum attribute. So 0.57, the ptnum attribute is equal to 0.57 because it is its own point number. So this works because on every single point, it checks for equality. It doesn't find equality until we get to 0.54, because then we replace this on the left. ptnum is actually 54 when we're on 0.54. And is that equal to 54? The answer is yes. So then it executes this line of code beneath. If you wanted to execute more than one line of code, you would have to put a curly brace. And then you put an ending curly brace. And let's clean it up so it looks nice. Now nothing changes, but now we have the ability to run something else. Let's say we want to also adjust the height of the point. So you could say at p.y, that is the position, and it is the y position, which is up in Houdini at least. Some software does not use y as up, but most 3D software is y up. And we could say equals point 0.1. Now you'll see our point moves up, and only our point that gets the red value. Quick example here. Let's just copy this over. We'll delete the bracket, or curly brace, make this look clean. But look what happens. Only our point 54 gets red, but all of the points moved up. See how the whole plane moves up? That's because this line is now out of the scope of our if conditional, and it's going to evaluate on every single point. So if you wish to do more than one line of code for an if statement, you have to put it in these little curly braces. Now this is not typically how you would do this. You can do the equals 0.1, but you are hard coding this y value to equal 0.1 no matter what. So let's just drop down a translate node, or a transform node, and let's move the grid up to 0.1. So we move it all the way up to 0.1 before we enter our wrangle. Now when we're on our wrangle, we're saying, okay, move this point that satisfies this condition to point 1, but the whole grid's already there. So typically in a wrangle, when you're doing something like this, you would use a plus equals sign, which is this. Now you'll see what happens. Now we get that 0.1 offset. Why? Because what's happening is it's going to add the value of 0.1 to whatever our p.y value was before we did this modification. So no matter where we move this grid, you can see that always has the 0.1 offset. So that's typically how you use that. Let's actually back this down to 0. We don't need it up there. And we'll recenter. Again, if you have no coding experience, plus equals, all that's going to do is say whatever is on the right, add it to the value on the left. So that's why it builds up on whatever value we already had there. It's going to add 0.1 to it and not explicitly set it to 0.1. Now, something else you can do is, let's say for all points that didn't meet this comparison, all the points that failed, you can have it run a statement for those, and you do that with an else. Again, if you wanted to do more than one line of code, you would do your little curly braces. Sometimes people just put them in by default, even if they're only doing one line of code. It just depends on how you want to write your code. And we could say, so if you're not 0.54, we're going to make you green. Why not? So CD equals, curly brace, 0, 1, 0. And now you'll see everything that is not 0.54 turns green. Now you might be thinking, well, can't you just assign everything to green after this if statement? Copy it, drag it over, and try it. What if we didn't put the else and didn't put the curly braces? What's going to happen? Everything turns green. Why? Well, we first test this for the comparison to 54, and we say, okay, yeah, make it red and adjust its height. But now outside of this if, it's going to just apply green to everything, no matter what. So it basically invalidates our work up here where we created the CD value. It's going to overwrite that with this CD. Let's delete this. Go back to this node. Now there's other cool things you could do to this. Now you might wonder, okay, well, what if we hit play? Okay, nothing really happens. Let's actually enable this little clock face here so we have 24 frames per second playback. It's just static. But here we're adding 0.1 to the Y position. However, it doesn't build up. There's a reason for that. Wrangle nodes have no concept of values off of the frame that you're on. So on frame 21, it looks at the incoming Y position, which is basically 0 because we're at the grid origin, and it adds 0.1 to it. You would think, okay, well on frame 22, shouldn't this move up? It's plus equaling, it's adding to the value, but no, it only knows what data is on that incoming channel on the frame that it's on. Now there is a way you can build up values over time. I'm not going to go into that now, that's more advanced. We'll cover that maybe later on. I'll give you a hint though, if you go here and hit tab solver, this is the node you use. I'm not going to show you that now though, we'll check that out later. This is just to try to give you a general understanding of how and why wrangles do what they do. So let's make this a little more fun and more interactive. It wouldn't be all that interesting to have to just hard code a number here and continually set it and change it. So we can do something like this. Just type CHI, so it's going to be looking for an integer channel, parentheses, and now you put your little quotation mark here, and we can say anything we want. Let's just say PT num. Close the bracket. And now you see it goes to 0. Well, because right now this PT num isn't really created yet. We got to hit this little plus, and you'll see what it says here, the little help that pops up. Create spare parameters for each unique call of CH. Now we called CHI, but it will still work. You hit this plus, and there you go. You get a PT num. It defaults to 0, but look what happens when we change the slider. Now our PT num is sliding through each point number corresponding to this. So at PT num is set to 3, you'll see 3 gets all this code run on it. Now obviously we have 99 is our end value because there's 100 points and everything gets indexed starting at 0, so our first point, if you want to call it point 1, is technically point 0. So we can change this. If you go up to your little sprocket, say Edit Parameter Interface, and you'll see under Generated Channel Parameters, we have PT_num. It defaults to a range of 0 to 10. Change that to 99 and hit Accept. Now you see our range slider goes way higher. We can go all the way to 99. So you could do something like set keyframes on this if you wish. You could also use $F, hit enter. Now see it says 22, we're on frame 22. We change to frame 72, it changes to frame 72. $F is how you access just the current frame of the time slider. But this isn't Vex when we're up here, okay? This is not the way you would access the frame number if you were down here. That could be a little confusing. If we actually try to access it the way you access it down here, it still works. $F is more of a legacy feature, I guess you would say. You can use @frame, and @frame is how you would access the frame value down here. Technically, I think you could still use the $F in the Vexpression, but it's uncommon. Let's see if it gives us an error. Usually people use the @. Let's see, $F. Still appears to function and work correctly. We're no longer using the channel feature up here. You know, we explicitly set it to $F, but you typically don't want to do that. So you can see that's a much more interesting, because then you don't have to actually keyframe anything or explicitly manually set a value in here. Now, what if you wanted to work on primitives? Instead of just having one point get a color, why don't we change this to a primitive wrangle? Let's copy it. Go to prim. You'll see technically the red color still works, but that's not really how you would do it with a primitive wrangle. You're still using PT_num, but we're in primitive mode. So all you got to do is change it to prim_num. That's how you access a primitive number. And if we enable our primitive numbers, you can see 0, 1, 2, 3. You can see we're on 1, and it does the exact same functionality basically. You might say, well, unfortunately, we always will never have 0 because our frame is never going to be on 0, but you could just say frame -1. Then it offsets everything, and then you'll have to be on frame 81 in order to see primitive 80 light up red. But you can always do mathematical operations on these things to change the values. But this is a little boring, having everything get set to green that didn't meet this comparison requirement, so we could do some cool things to change that. Let's say if you are not the prim number that is equal to the current frame number, or our variable up here, let's change this. Let's say rand. Now you'll see it gives you a description of what it does. If you've never seen this before, all it's going to do is generate a random value between 0 and 1 from a seed. If you don't know anything about random number generation, the seed value will just change the random number that it spits out. So we're going to want that to be unique for every primitive so that we get a different color, and we can easily just use the primitive number as our seed because it is different for every primitive. So just type @prim_num. And look at that. We get a completely random assortment of colors. Now it's a little hard to see our red sliding through that because of how bright these other values are, so you could always just then multiply these down by say 0.25. Now you're going to drain 75% of their intensity out. It makes them almost a grayscale look here. So if you don't want that to happen, you can do it after the fact. So you could do @cd times equals 0.25. Now we're changing that set value down to something lower, which might be what you want, but now you can see our red much better going through there. Now, what if you wanted these to actually change every frame for some reason? Maybe you want that. That's also very simple to do. How would we do that? Well, we would want our seed value to change with every frame, because that would then spit out a random color every frame. But we still want to use our primnum as part of the seed so that it is a different value for every primitive face. Easily can be done. Just multiply our primnum by our chiptnum. So you could technically just go up here and copy and paste to make it simpler. Now what's happening? Everything turned one color. You don't want that. It's also a fairly ugly pea green color. So the problem is here, if we look at this channel that we're sampling, frame -1, on frame 1, that's going to spit out 0. By the rules of mathematics, any number multiplied by 0 becomes 0. So primnum on every face becomes 0. If you look at how this thing works, and we know that it's going to run over every single primitive, on primitive 0, we have 0 times chiptnum, which is 0, makes 0. On face 80, when we get all the way up to primitive 80, you have 80 times 0 is 0, so they will all get the exact same random number generated. That only happens on this first frame. You can see it then changes as we go along. However, you wouldn't want this. This would be considered an error. So that's also very simple to fix. You just want to put a parentheses around your little CHI here, and then just hit +1 and a clothing parentheses. Now we've just added 1 to this. So no matter what, it'll always be 1 more. So on 0, it's actually equal to 1, and so on and so forth. You get the idea. You see it still now does everything we want. The color values are still a bit bright to really make our red stand out, so you could go even lower here. Makes the red stand out a little bit more. We could go even lower to really make our red stand out. Let's disable these displays here and just hit play. So that's kind of cool. But you'll notice after frame 80, or is it 81 here? 81 because we did our offset. Our red disappears. Our random color keeps going, and that's cool, but we lose our red. So what if we wanted to make this cycle? Okay, so that once it gets here, it just restarts on frame 82 or whatever. It's going to jump back to this one and just run through it. It's easy to do. It's Houdini, so there's a lot of procedural stuff here we can do. So we can go up here, and let's encapsulate this with parentheses. And use the symbol that is on the 5, sometimes referred to as modulus, sometimes referred to as modulo. This can be quite confusing for some, so I'll try to explain it briefly, but you should Google this if you have never ever seen or heard of this. But let's just do modulo 81. Now you can see, look, it automatically goes back there. And let's rewind and hit play. And you see it run down every single primitive, and then it gets to the end, and then it goes back and just keeps running. Very simple way to have this thing just perpetually scan through these. Imagine if this was like an array of pixels you're scanning through. Why does this work? Okay, I'll do my best to explain it. Modulo, or modulus, sometimes it's referred to as both. Technically, I think modulo's more accurate mathematically, and if you're going to Google it, you're probably going to want to search for modulo. What it does is it returns the remainder of. So let's just click on this so we can see what's happening. This, keep in mind, this number here is the result of this expression running. You can consider it an expression here. Once we get to 81, it resets. And why is that? Well, on frame 82, we have 82 minus 1, which is 81, modulo 81. So 81 divided by 81 is the value 1 with no remainder. It's 0, so it's going to give us 0. I don't know if that's confusing or not. Think about it. 81 divided by 81. If you use a calculator, it's going to show you 1, and there is no remainder because it's an even division. Anytime we're not on an evenly divided number or an evenly divisible number, it spits out a remainder. And the way it's doing that in Houdini is just, now we go to frame 83, which now its result is 1. So that's 83 is the frame we're on. Minus 1 is actually then the value of 82. 82 divided by 81 is 1 with a remainder of 1. That's why it evaluates to 1. And that's why it then works to run down all of our pixels here, if we want to call them pixels. If that's confusing, you can try to reach out to me, or I would suggest Googling modulo. I'll spell it here on the screen. There'll be probably hundreds of thousands of results from mathematical resources or programming resources that explain this. But this is a very simple line here. I mean, we almost did nothing, and we have this automated thing that'll run through every single primitive on this and then loop for us without us having to do much work. That's one of the powers of a wrangle. It would be very, very unpleasant to have to hand keyframe this and then sawtooth it back to the beginning range once we get past the number of primitives we have and so on and so forth. So a little bit of simple code makes it simple. Now, what if you wanted this to not go in this linear fashion? You wanted this red square to just jump all over the place. That's simple too. We already have this value that's changing every frame. So we can just use this. We could say, let's remove this. Actually, let's duplicate this. It's very simple and easy to just duplicate a node, and then if you screw something up in here, you always have your master copy to go back to. So let's just modify this and say, actually, we'll still keep this CHI since we're going to need that. We'll go rand. Now this is not going to work. You see it completely disappears. But you can use something called a fit01. So let's do fit01, and it's going to tell you some help here. Takes the value in the range 0 to 1 and shifts it to the corresponding values in a new range. And you'll see it's telling you to put the value first, and then the new minimum and the new maximum. So this first value that we want is going to be, in fact, this rand chi pt num. So then you put a comma, and we want it to give us values between the range of 0 and 81. And then we do our end parentheses here. Now you see it still does not work. And the reason is this is probably actually outputting some fractional number here. It's probably outputting something like, say, 52.3. And since there is no primitive number that will ever equal 52.3 or any fraction, it won't work, but we can do something very easy to fix that, called a type casting, or a cast to a different type of variable. So you can just type int, parentheses, and then an end parentheses after all of this. And now you'll see we get a random face picked. It happens to be 33. And if we play this out, you'll see that it just randomly picks faces, or primitives if you want to call them primitives. Now make sure if you're copying this that all of your parentheses are in the correct spots. Any one of these in the wrong place will make your code not evaluate. It will almost always be a human error and not the error of the software. Especially when you start getting a lot of these functions strung together, you will have a lot of parentheses, and a way you can usually check to see if you're doing it right is to count your opening and closing parentheses. So we know that this is our block we are working on here. If there's an error, you could count these and say there's 1 opening, 2 opening, 3 opening, 4 opening parentheses. So we know we're going to need 4 closing parentheses, or else we won't have correct syntax. And look at that, we have 1 closing, 2 closing, 3 closing, 4 closing. But the number of parentheses isn't the only thing that matters. You got to make sure they're in their correct locations, so make sure you follow this accurately. Open up the scene file if you have any issues or it's hard to see. Sometimes the compression of the video can make it hard to see this code. That's why the scene files are always included. If you have no experience coding, it'll be very likely that you're going to have some of these in the wrong place or not have the corresponding correct number of opening and closing braces. Don't worry about it. I mean, it takes a while to become good at programming. Just look through your code. A lot of times it'll give you a syntax error that will help you track down where an error is. A lot of times the syntax errors are useless though, so you will still have to manually search through and just find it and correct it. So there's one more thing I'm going to show you to wrap this up. There's something called the detail mode. So let's just drop down a new wrangle. And you can drop down a detail wrangle or almost any of these. You could pick a primitive wrangle just for sake of example and change it to detail. Let's plug our grid into it. And now let's check it out. Tells you right here, run over detail only once. So instead of doing what it's been doing in all the other modes, running over each and every point or each and every primitive, this only works once on the entire set of geometry here. So if you wanted to say what we already did, let's just do it real quick. If at pt_num is equal to 0, let's make it red. What's going to happen? Nothing. It doesn't work. Let's try prim_num. Doesn't work. Well, these attributes don't really exist in this mode, so you can't do it that way, but there's always a way to do something in Houdini. So when you're in detail mode, and let me be honest about this, out of all the times I use Wrangles, I go into detail mode maybe 2 or 3%. So like 97% of the time I'm using Wrangles, it's in point mode. Then the next most common mode would be primitive, and detail is very rarely, but sometimes you actually want to do that. Detail mode allows you to basically write a block of code in a more traditional sense where you can have, say, a for loop, and you can actually look at data from each face and even, like, say, store it in an array and then look at values to make comparisons. It's a little more advanced. We're not going to go into this for this basic overview of how Wrangles run. I don't want to confuse anybody too badly. But just know detail mode allows you to do some things that are not that easy to do in the other modes. I'll show you a quick example of how we could work in detail mode. We know that we have 80, let's see, this is our primitive face. So let's go to point numbers. We have 99 points, which mean we actually have 100 points because, of course, the index starts at 0. But so if we did a for loop, let's say for. And if you know nothing about programming, again, you should check out for loops. You can Google search for this. There'll be tons of information out there. A for loop is just going to basically allow us to run over a set number of points here in this case. So let's just say int x, lowercase x, is equal to 0. Then you use a semicolon, and then you say x less than 100. And I'll explain this when I'm done, semicolon. And then we say x plus plus, and parentheses, and of course we're going to do our curly braces here. Now what is this doing? You see nothing happen because we've done nothing yet. All we've done is initialize a for loop. The first parameter here, int x, we're defining a variable, an integer variable called x, and we're making it equal to 0. The next block here is going to say, while our x variable is less than 100, do this. That's shorthand code that means that every iteration it's just going to add 1 to the previous value of x. So we start with it being 0. Then the next condition says, is x less than 100? Of course 0 is less than 100. So then it says, okay, after this code's done, x plus plus, make it equal to 1. Then it runs it again. X will be now equal to 1. Is 1 less than 100? Absolutely. So then it'll add 1 to it again, and so on and so forth. And it keeps doing this. Once it gets to say x is equal to 99, it says, is 99 less than 100? Yes. So it runs it again. Then it says, okay, is 100 less than 100? No, it isn't. So then the code in this block will stop executing. It'll no longer function. But this then allows us to run over every point again, even though we're in a detail mode where it's only going to run once. This code is running once, but a for loop is going to execute however many times we set here. So that's how we can keep running it over and over again. And I'll give you an example of how you would use this. We're going to use, let's see, we're going to set it on a point. So let's do set point attribute. Now there's a lot of things this is going to look for. You need to tell it a geo handle, which is basically just going to say what geometry do we want to set this point attribute on, and it's our incoming geometry, so we just use the value of 0. All those inputs that are on these wrangles are labeled 0, 1, 2, and 3. Remember, indexes start at 0, so the first input is actually number 0. Then string name, we're going to want it to be CD, and then int point num will be whatever point number we want. And then the value, so we're going to put our color there, and then the string mode, we're going to have to actually tell it to set it. So let's see if we can even remember all these things once this little screen disappears. Then we do point number. So let's just pick 54 again was our middle point. And then the value we want to set is going to be color. So we're just going to do our red. And then we actually have to tell it set. And then we close it down how we always do. And look at that. Now we get 0.54 again, red. Would you do it this way? No, you absolutely would not do it under a detail mode. If you wanted to do what I'm doing right now, it'd be completely unnecessary, but I'm just showing you how you use a wrangle when it's set to detail mode. We can make it a little more interesting here by setting a random value. So let's just do a vector rand color, and we have to spell it correctly. Vectore does not work. Vector. And we will say equals. Now, because we're going to be assigning random values to our X, Y, and Z or our RGB, we got to do a different method here. You have to use a set function. And it'll tell you some stuff here. Just remember, if you're trying to assign random values to individual components of a vector, you got to use set. That's just how Houdini makes you set it. So we can then say rand, and we can do X. Because remember, X is now equal to our point number. So this will be our random seed. And now you can do rand. And you can do X, but let's offset it so it's slightly different for our green value. And then the same thing for our blue. Let's do X and say +2. Close it down properly. Now nothing's going to happen because we haven't actually used this rand color yet. But now we can replace this with our variable rand color. And we also need to now tell it to run over X, or else we're only going to set that random color to 54 as you saw. And now look at that. You get a psychedelic grid here. Now again, would you go through all of this to do something like this? No, absolutely not. You would do this all in point mode. I don't want to discourage anyone from learning Vex, but if you really wanted to do something like this, you could just do an attribute randomize. And you can see you get nearly the identical result here. Like I've said in all of my lectures, if you've ever watched any of my other lectures, and I'm going to sound like a broken record, guess what? You can do the same thing in Houdini countless different ways. It's up to you as the artist to choose which method you want to use, but I'm going to delete this because this is not about the attribute randomize nodes. This is about using wrangles and getting to understand the basic functions of wrangles. So with that being said, I think we've covered enough to give you a general overview of how a wrangle works. Just remember, every single point when you're in point mode is going to run the code that's in this Vexpression block. And ptnum is always going to be the number of the point that the code is currently running on. Also remember that these values do not persist. They do not exist on any other frame than the frame you're currently on, so you can't build up values over time. 24 is going to set it to this 0.1 height. 25, it's still just going to be 0.1. Even though we're plus equalsing, it's not going to get cumulative. It's not going to add up. We can actually do that with the solver sop, but we're not going to go over that yet because that's a little more advanced. We'll check that out later on. If you want to see a more general overview of how all of Houdini works, you can check out my Udemy course. I still have 3 courses over on Udemy, even though I'm now transitioning off of the platform. There are still 3 courses over there. It's called Master Houdini FX. I will leave you a link in the description with this video. If you do choose to purchase it, please use the link. Udemy takes a gigantic portion of the sale when you go to their site and just pick the course off of their site. However, if you use an instructor's actual link to it, then the instructor gets the majority of the sale, so it helps greatly. Because believe it or not, it takes a lot of time to create all these lectures and videos, and every little bit helps to give us the ability to continue to make these courses. So that's all we're going to cover for this one. Stay tuned and keep watching for the upcoming lecture that will show us how to use our solver sop so we can build up values over time in Wrangles, which opens up the door for many, many cool setups and rigs. There's quite a bit you can do with that solver sop, so stay tuned for that. And I hope you like what you saw in this lecture. Thank you for watching, and I will see you in the next one.